Okay. First thing that we want to talk about is how do we write our polynomials? So what we learned last week is how to use polynomial division to divide, right? So here's a basic question. We have x squared plus 5x plus 6, and we want to divide it by x plus 1. All right. Looks like we all successfully know how to do this now, which is good. X into x squared is x, and then, multiply it. And we subtract 5x minus x is 4x, but then you can't have the one term, so you bring that down, plus 6, and then do it again, plus 4, and then multiply, we get 4x plus 4, subtract, and we get a remainder of 2. Now, last week I would have just said, just for the time being, because I didn't want to overload you with, the content, I just wanted you first to learn the division. I said, just write it the way you would have written it back in primary school. It's fine, right? X plus 4, remainder 2. Because technically it is true. But the reality of these questions is you're trying to write them in this form. So P of x equals A of x multiplied by Q of x plus R. Now, can anyone see how to write this x squared plus 5x plus 6 in this form? Something multiplied by something plus 2, plus the 2, which is the remainder, needs to give me the x squared plus 5x plus 6 again. So what two things multiplied together? So what are these two things, you think?
X plus 1 and x plus 4.
Yeah, exactly right. So essentially, there's fancy words for these. One's called the divisor, and then the Q is technically called the quotient. So this thing is the one that you're dividing by, and then this is the result that you get when you divide, right? The quotient. But very fancy word that you don't need to know about too much. All you need to know is, yeah, this times this plus this should give me x squared plus 5x plus 6, right? X plus 4 times x plus 1 plus 2 needs to give me x squared plus 5x plus 6. Does anyone disagree with that or not sure how that's true or why that's even true? Because I can show you a very simple case, unless you understand it and agree with it.
Could you just explain it?
Yeah. Well, let's do a basic long division. Give me two numbers that you want to divide by, just basic numbers. Let's say 33 divided by 5. Right? How many times does 5 go into 33? 6. Remainder of 3. We agree with that? So Anthony, if I told you, now that you know 33 divided by 5 is 6, remainder 3, can you write this in another way? How else could you write 33? Using these numbers, 5, 6, and the remainder of 3.
6 times 5 plus 3.
Yeah, see that?
Yeah.
That's exactly what you're doing here. X plus 4 times x plus 1 plus the remainder of 2. That's exactly what you guys have done before, but you probably, never put it together because these were all numbers, so this is very common sense to you. Whereas this felt like, whoa, what the hell are we doing? But you're actually doing the exact same thing. X plus 4 times this, plus any remaining must give you your original. Anthony, 100%?
Yeah, 100%.
So do you even feel like you should memorize this?
No.
Not really. Look, the less, because look, this is all the math you guys are going to learn, right? Let's just draw a line. This is all the math you learn in high school. Now, imagine if I can simplify that and even half it. Right? If I say, hey, all we need to know is all of this actually overlaps with all of this. So as long as you know this amount, you're good enough. you're not, the less you can know and the more you can link with something else that you actually already know, the easier it becomes for you. So I'm trying to show you guys, this is fancy, but I don't know if anyone actually memorizes. The ones that memorize are the ones that don't know what's happening. For those who just link it to something like this, they go, oh yeah, these two multiplied, plus the remaining must give me my original again. So the less you can memorize, the easier it's going to be for you long term. There's going to be a lot to memorize if you could obviously understand that. So cool. All right. Let's do it again just to make sure we can write those in that form. X squared plus 6x minus 9 into, x minus 2. And then we just do the same thing. X into x squared is x. Multiply. Subtract. 6 plus 2 is 8. Bring the minus 9 down. Go again. Plus 8. 8x minus 16. Minus 9 plus 16. 7. And therefore, what does that mean about x squared plus 6x minus 9? What is it equal to? What must it equal to? It must equal to x minus 2 times x plus 8 plus any remaining. Now, anybody have a way of how I can check if that's actually even true? I'm saying it is. How can I check if that's true?
Actually solve it.
What do you mean? Don't say solve. The E word.
Evaluate.
No.
Equations.
No.
Expand.
Expand. I'm only going to expand this. And if it's right, it should actually give me the left side. So let's see. X times x. X times 8. Minus 2 times x. Minus 2 times 8. Plus the 7. I get x squared. 8 take away 2 is 6. Minus 16 plus 7 is, oops, is minus 9. So it works. So it is true. Anthony, isn't that exactly what you technically would have done when I would have said, hey, can you check what that equals to? Wouldn't you just expand it almost?
Yeah.
6 times 5 is 30. 30 plus 3 is 33. So again, same logic. Ever needed to check? Very simple. Okay, good stuff. I'll pause that video. What are you, any